Welcome, soil conservation and management students, to our Session 13 lecture series on soil resilience. Lecture 13, or Session 13, is broken down into 6 video lectures. In the previous video lecture, we talked about concepts and importance of soil resilience, and in this lecture number 2, or video lecture number 2, we're going to talk about classification, soil resilience, and soil disturbance. These lectures were recorded for students at the Royal University of Agriculture in Phnom Penh, Cambodia. And I am Dr. Jared Williams with Brigham Young University, Idaho in the United States. Okay, let's begin today's video lecture by talking about a classification of soil resilience. A classification of soil resilience is going to be based on the type of degradation that occurs. What is the type of degradation? And that's such as soil erosion, which we see here, some soil erosion occurring right there, soil erosion, and drainage, and then also salinization is another one, and we have some soil salinization here. You can see that by looking at the salt that's accumulating on the surface. Okay? And so that is one way we can classify it. The other thing is to realize that soils are diverse, and their response to soil disturbance and soil degradation, I'm going to write disturbance here, disturbance and degradation is going to be complex and varied. Okay? For example, if I have 2 different soils that are under the same management practice, and so the management practice disturbs the soil, the soil's response to that, or ability to return or bounce back, a term I used in the previous lecture, to the previous state, pre-disturbance state, will vary. It will be different, and it will really be different based off of profile depth, topsoil depth, to some extent, topsoil and subsoil, horizon thickness, how thick is the A horizon, or the O horizon, or the B horizon. Typically, we're thinking A and O horizons, okay? And also the soil organic matter. Okay? What makes soils resilient is, it really comes down to soil thickness, I can spell that, thickness, soil thickness, and soil organic matter. Okay? And this is a theme, or some points that you will see me continue to talk about throughout this lecture series. Okay, soils that are thicker, get the screen here. Soils that are thicker versus ones that are thinner will have more resilience. Thicker soils, more resilient. Organic matter, more resilient, and that's simply because if I have a thicker soil and I lose a little bit, it will still be able to produce. Also, soil organic matter helps hold the soil together, and it helps recreate some soil and improve soil quality. Another way we can classify soils is in this chart here, okay? And this is based off of some classes. So here at the very top, we have our class 0, which are our highly resilient soils. Okay? On the bottom, we have our least resistant, soils that just won't bounce back, and you can see at least non-resilient there. In the middle there somewhere, we've got our moderately resistant. Okay, let's talk about each of these soils and some of the properties that come along with them. Change to green here. So, as we'd expect, resilient soils high resilience, recovered rapidly. They rapidly recover, and they can also buffer or withstand the change. Okay, and so these soils are going to be non-erodible. Right? They have soil properties that allow to prevent soil erosion. They also are normally fertile soils, healthy soils that produce plenty of biomass that helps cover that soil surface and protects the soil surface as well. Roots that bind soil particles together. So as would be expected, they're going to be deep, very deep soils, and they're going to have very high organic matter, aggregate stability, and water infiltration. Whereas soils that have moderate resilience, okay, they will recover, but they need high input. We have to add materials back to them to help them recover. Whereas our highly resilient soils don't require those high inputs. Okay? These soils are erodible, not highly erodible, but erodible. They are moderately deep, right? They have some depth, and they have some organic matter and aggregate stability and water infiltration. But in order to recover, so there's some resilience, but they need some help with it. Okay? On our bottom one here, our bottom classification, look at this, no recovery. These soils do not have the ability to recover, even with land use practices or management practices. Okay? They are extremely erodible. They are shallow, okay, not very, very thin, and they have low organic matter and aggregate stability. In general, these soils typically, and not always, but are typically from arid regions. And in many arid regions, cannot recover after soil disturbance because there's not the moisture or water there to support the plant growth and biological activities required for recovering. Okay? Also, our highly resistant soils tend to be soils with high rainfall or in tropical regions. Now, again, please understand that there are soils in tropical regions that would be non-resilient, and there are soils in arid regions that could be classified as highly resilient. Okay? But generally speaking, tropical soils tend to be more resilient, and arid region soils tend to be less resilient. Okay? And again, most arid soils are probably in the 2 or 3 classification, not the 4. Okay? But classification 4 is dominated by arid region soils. Okay? What are some of the disturbances that are out there, and how do they impact things? And so soil disturbances are going to be classified or anything that changes or alters the soil from its normal function. Now, those changes can be very rapid or they can be very, very slow. We also can classify these into 2 categories, our natural disturbances and our anthropogenic disturbances. Anthropogenic disturbances mean human caused. These would be human caused. Okay? Natural disturbances are occurring, and soils that often form with natural disturbances occurring. So they already have some resilience to these natural disturbances. And some examples of natural disturbances are landslides, earthquakes, windstorms, rainstorms, droughts, and floods. And again, these soils, the soils where natural disturbances are occurring, have always had natural disturbances. So they're already, if you will, they've already developed resilience to these natural disturbances. Not always, but for the most part. Whereas anthropogenic activities are typically rapid and new. We have things like deforestation, tillage, the farming practices and cropping systems that we use, salinity introduced by our irrigation water, or urban development. Okay? These soils didn't form with these disturbances occurring. And so, unlike natural disturbances, human-caused or anthropogenic disturbances have a huge or a large impact on soils. Okay? Unlike our natural disturbances, which the soil has already built a natural, if you will, immunity or a natural resilience to, they don't have a resilience to anthropogenic disturbances. And so anthropogenic disturbances can greatly reduce a soil's resilience. Okay? That concludes our video lecture number 2 on soil resilience classification and soil disturbance.